The LincolnLog valve has been designed for both high-end performance and ease of maintenance. All components are accessed via the top entry bonnet design. Standard studs and nuts hold the bonnet flange, bonnet, and bonnet seal in place. All trim components are held in place by the bonnet and are removable without special tools. In spite of the complex flow path geometry of the plug and liner, they are single parts that lend to ease of maintenance. The seat ring and its gaskets are clamped by the liner. For the smallest sizes, the seat ring is an integral part of the liner. The packing box design is a conventional multi-ring configuration with flange and follower. Recommended spares for unit commissioning include a packing set, a bonnet gasket, a plug seal, and seat ring gaskets. Your LincolnLog valve can be serviced and inspected with minimal manpower and conventional tools. The phenomena of cavitation in control valves can be likened to a variable orifice in a pipeline, with the valve plug providing the flow restriction. As flow accelerates across the plug, the pressure energy of the fluid is temporarily converted to velocity-related kinetic energy, similar to acceleration through the vena contracta. At the vena contracta, where fluid velocity is highest, the fluid pressure drops to its lowest local level prior to recovery further downstream. If this local low pressure drops below the vapor pressure of the fluid, then vapor bubbles begin to form. These vapor bubbles are converted back to their fluid state as pressure recovers downstream, and the collapse of the bubbles creates a microjet of high-velocity fluid. If these jets impact the valve body or trim, they can be very damaging in a surprisingly short period of time. Where high-pressure fluid is being subjected to large pressure drops, cavitation is always a concern. The often told industry comparison is that the phenomena sounds like gravel flowing inside the pipeline. If that sound is being heard, cavitation is definitely present and damage is occurring. The Masoneilan LincolnLog anti-cavitation valve is the industry standard solution for handling high-pressure liquid letdown and avoiding cavitation. The unique three-dimensional axial flow path of the LincolnLog controls pressure reduction by breaking the total pressure drop into multiple stages. Although each stage has a local overshoot and associated pressure recovery, the local pressure never drops below the fluid vapor pressure. In fact, as the pressure approaches P2 in the final stages, the pressure reductions are intentionally smaller, which guards against dropping below the damaging threshold of vapor pressure. Additionally, by managing the pressure drop in stages, the associated short-duration low-pressure, high-velocity instances are also minimized, which serves to manage the associated noise and damaging effects of high trim velocity. The LincolnLog employs a unique three-dimensional axial direction flow path. Each pressure reduction stage forces the fluid through axial, radial, and circumferential channels that progressively reduce the pressure energy of the fluid. Within the trim, there are 6 means used to reduce fluid pressure by creating flow resistance and fluid friction. Both contraction and expansion, as well as directional turns, coupled with merging and splitting of flow paths, all employed across multiple trim stages, provide predictable and repeatable pressure reduction. A notable feature of the LincolnLog trim design is that all stages are actively controlled in unison with plug movement. The proportional resistance created by this unison staging provides the necessary predictable fluid energy management for high-pressure drop applications. This predictable reduction at each stage concludes its mission with a smaller managed pressure drop at the final stage where cavitation risk is greatest due to the adjacent P2 pressure. The LincolnLog valve brings rugged performance to severe applications via its heavy and continuous plug guiding. In spite of its multi-directional flow paths, the plug maintains continuous guiding along the liner, which is hardened stainless steel. This uninterrupted guiding serves to minimize vibration while the trim is under significant load from multi-directional fluid forces. The bottom line for the user is extended trim life and reduced process downtime. It goes without saying that all users desire a control valve that provides smooth performance under all operating conditions. The LincolnLog meets this expectation with its axial flow multi-stage trim design. Competing radial flow trim designs are subject to sharp incremental CV changes along their performance curve. Additionally, low flow plug positions can result in the full pressure drop across a single stage, which leads to damaging erosion at the seating surface. Alternately, the LincolnLog provides smooth, continuous control across its entire travel span. Another important feature of the LincolnLog design is its performance at low travel positions. The first and second stages of the plug are designed with an intentional overlap, which prevents the seating surface from throttling high-pressure drops. The result is extended service life for the trim while maintaining specified shutoff performance. This seat protection feature plots as a slight flattening of the performance curve at low travel, which then transitions into a smooth linear characteristic for the balance of travel. The flow-up orientation of the trim ensures dynamic stability at low travels and serves to minimize required actuation forces. In addition to best-in-class throttling control, the LincolnLog design also provides reliable tight shutoff. The primary seat-to-plug contact is a metal-to-metal interface that meets ANSI Class 5 shutoff requirements. Optional block valve shutoff to meet MSS SP61 is also available. The LincolnLog can also be configured with an optional protected soft seat design that extends shutoff performance to ANSI Class 6 requirements. This option employs a PTFE seat insert that is held in place by a stainless steel collar. Fluid forces and the elastic resiliency of the insert cause the sliding collar to return to a protective shielding position when the valve plug is opened. The loading of the plug during seating pushes the collar down to permit engagement with the PTFE insert. The result is bubble-tight Class 6 shutoff performance with many years of field success. The LincolnLog design is often specified by users for its ability to operate under the potentially damaging effects of flow-entrained debris. This debris can be either unintended pipeline trash, or predictably dirty fluids, or even catalyst solids. The large openings of the unique LincolnLog trim provide excellent tolerance of solids that are able to pass through the trim without clogging. For users, this means reliable service under difficult conditions like plant startup, and ultimately it means the protection of critical plant assets. Competing designs with small drilled hole trims are not able to provide this type of uninterrupted service. LincolnLog design is available in a variety of trim configurations. Unbalanced trim designs provide secure tight shutoff, meeting ANSI Class 5 and MSS SP61 specifications. Bubble-tight Class 6 shutoff is available with an optional soft seat upgrade. Balanced trim designs are also available, which reduce required actuation forces by equalizing pressures acting on the plug when seated. The LincolnLog product family includes 3, 4, and 6-stage trims, with a wide variety of staging ratios that are matched to the application. This ability to customize the product within standard options means that the LincolnLog can be configured to fit most any high-pressure, severe service liquid letdown application. For application parameters that exceed the standard options, Masoneilan Engineering is available to configure additional and custom stage trims to meet user needs.